In example 4, we're given the graph of a quadratic function below, and we need to state all the following. So here's our graph. It's a parabola, U-shaped. The very first thing we need to find are the x-intercepts. Well, the x-intercepts are going to be just like when we found linear x-intercepts. It's where the graph crosses over the x-axis. Here's my x-axis, so I'm looking at what point, at what x values does my graph cross over. And I can see my graph crosses over here and over right here. So at -1 and 3. So I can say my x-intercepts are when x equals 3 and -1. Next, I need to find my y-intercept. Well, my y-intercept is when my graph crosses over the y-axis. So as I look at my y-axis, the graph crosses over the y-axis right here at this point, and that's at the point -3. So I can say my y-intercept is -3. The next thing I need to find is the vertex. Remember, the vertex is either the highest point or the lowest point of your graph. So my vertex is going to be right here. Since it's opening up, it's the lowest part of my graph. And it's this point right here, which is the point 1, -4. So I can say my vertex is 1, -4. Next, I want to find my domain. In my domain are all my possible x values. So again, domain is all the possible x values. We talked about domain and range with our lines as well. If I look at my x values, I'm trying to see if I will have every x value have a point somewhere on my graph. And what I need to realize is that this graph on the right is going to continue to go up. And as it goes up, it's going to also go to the right. This graph on the far left, as it goes up, it's also going up on a diagonal, so it's going to start heading out to the left as well. Which means every point that I have, every x value I have, will find a point somewhere on my graph. So -2 has a point up here. -4 eventually will have a point up here. Same thing with -5, it will just be a little bit higher up. But all x values are a possibility, which means that my domain, we would say, is all real numbers. Then if we take a look at the range is all our possible y values. So can we use every single y value? Well, if you take a look at our graph, it is going to continue to go up. So it will take care of every y value in that positive direction. However, our graph at the bottom here is not going to continue to go down. It starts here, right here, and it goes up. It doesn't take any of the numbers below it. So we can say that our range is going to take all y values from -4 up. And so we would say y is greater than or equal to -4. The zeros of my function, the zeros of your function are the same as your solutions and your x-intercepts. So the zeros of my functions, the zeros and the x-intercepts are always going to be the same thing. So my zeros are the same, which is 3 and -1. Zeros means when is the x, or when is the y value going to be 0. Letter G asks, does it open up or down? And we already talked about that. This graph is opening up. So we would say up. Maximum or minimum point, well, since our graph is opening up, we have this smaller point down here, which we call a minimum point. So we would say minimum. And finally, the axis of symmetry. The axis of symmetry is the line that's going to split that graph directly in half. And remember, it also goes directly through the vertex. So here's my vertex. So I'm looking at this line right here. And I'm going to draw that line in for you. Actually, let's use a different color so it's a little bit easier to see. So that line right here is a vertical line that goes directly through my graph and through my vertex. And this is a line of x equals 1. If you have questions, let me know.